In today's video, we have some problem on the board that is a Sturm Liouville problem. So let us consider this. Determine which of the following differential equation with the boundary condition y of 0 is equal to 0, y prime of 1 is equal to 0 form a Sturm Liouville problem. We want to consider some question. I have other question here from a question of A to E. Is it a Sturm Liouville problem or not? So let us consider this first question. Exponential to the power of x y prime prime plus exponential x y prime plus lambda y is equal to 0. Is it a Sturm Liouville problem or not? When I talk about when we talk on Sturm Liouville problem, it means it must be in form of this. If this one satisfies this and all these are continuous, that is P of S, P prime of S, and Q of S and W of S are continuous on A comma B, and both P of S and W of S are positive on A comma B. If you satisfy this, so it is a what? It is a Sturm Liouville problem. You can see that we have our boundary condition, that is 0, y of 0 is equal to 0, y prime of 1 is equal to 0. So it means it is continuous, that is it is continuous on what? On 0 and 1. That is, it's continuous on 0 and 1. So let us now discuss that first example. Exponential x y prime prime plus exponential x y prime to lambda y is equal to 0. So I can write this exponential x y prime plus lambda y is equal to 0. Yes, it means I can form this in this form. That is, the reason why is that if I differentiate this exponential s y double prime plus exponential s y prime, it means in this, if I open this bracket, that is, if I differentiate by opening this bracket, I'm going to have this. If I open this bracket, that is, if I differentiate this by opening this bracket, I'm going to have this. It means if I use product rule to solve this, I'm going to have exponential s y prime. Differentiate again, I'm going to have exponential s double prime y double prime. So that's why I have this plus what? Y prime. Then differentiate that with respect to x. I'm going to have d all over ds exponential s. Then if you do d of ds exponential, you're going to have what? Exponential s multiplied by that y prime. So that's why we have this. You can see that if I open this, I'm going to have this. So it means I can write this. So it means I can write this in form of this, then plus lambda y. So remember that our P of s, the coefficient of y double prime is P of s, the coefficient of y is P of q of s, and the coefficient of y to the lambda is what? W of x. So what is the coefficient of P of x here? P of s. So what is P of s here? Our P of s here is exponential x. What's our q of x? Q of s is what? The coefficient of y to y. We don't have it here. Then our W of s is the what? Is the lambda to what? Lambda of y. So W of s is what? The coefficient of what? Lambda y is what? 1. So you can see that we have P of s exponential x. You can see that this form a Sturm Liouville problem. And for this one to form a Sturm Liouville problem, we will now check if they are both if both P of s and W of s are positive. If they are positive, so let us check. So it means for this one to be what? P of s to be positive, we have exponential x. So it means if I said P of 0, I'm going to have exponential 0, which is called, I'm going to have 1. Then Q of x is equal to 0 and W of s is equal to 1 already. The way I get exponential 0, that is our P of s, that is it is a Sturm Liouville problem. Sturm Liouville problem. It is continuous. It is continuous on 0, 1. Yes. Remember that this statement said that our P of s and W of s are positive. You can see that W of s already is positive 1 and P of s is exponential s. So since it is continuous on 0, 1, so it means whenever I see x, I put 0. So if I put at x equal to 0, I'm going to have 1. You can see our P of s is constant and W of s is constant. So Q of s can take any value. but P of S and W of S must be both positive. Since they are both positive, it means it is what? It is a what? It is a Sturm Liouville problem. So let us consider another example. S y point point plus y point plus s square plus 1 plus lambda y is equal to 0. Is this a Sturm Liouville problem or not? So let us consider this question. So I can write this one as, if I open this bracket, I'm going to have s y prime prime. If I now differentiate this with respect to x, I'm going to have 1. 1 times y prime, I'm going to have y prime. So that's s y double prime. I can write it like this plus, let me open this bracket. So s square times 1, I'm going to have s square y plus lambda y is equal to 0. So for me, I can have sy prime prime plus s square. Y is common between them. Y s square plus 1. If I set y multiplied by this, I'm going to have this. Then plus lambda y is equal to 0. So is this a Sturm Liouville problem? You can see that it forms a Sturm Liouville problem. So where is our where p of x, where p of s is what? Sy prime. It means x. Our p of s is x. Then what is our q of s? Our q of s is s square plus 1. The coefficient of s square plus 1. Why our w of s is? What is our w of s? W of s is what? Lambda y. So the coefficient of lambda y is what? 1. So is it a Sturm Liouville problem or not? So let us put when s is what? When s is 0. So if I put when s is 0, I'm going to have 0. So it means if I put when s is 0 here, I'm going to have what? At s is equal to 0, I'm going to have 0. Since p of s is not equal to what? It's not positive. So it means it is not a Sturm Liouville problem because it is not continuous on what? On 0, 1. It means our s is what? 0. So we are using this to, when it satisfies all this, it means it's a Sturm Liouville problem. Since p of s is equal to 0 at a point a point of interval, at a point of interval 0, 1, and since so it is not Sturm Liouville problem. Sturm Liouville problem. It forms a Sturm Liouville problem, but P of S and P of S does not satisfy. Suppose if our P of S here is what? Is positive, and our W of S is what? Positive already. It means if W of S is positive, P of S must also be positive. But if one fail to be what? To be, if one fail, it means both of them. It means it does not the Sturm Liouville problem. As you can see that we form a Sturm Liouville problem, but it does not satisfy the P of S and W of S. And P of S and W of S must be both positive. So let us check our third example. 1 over x y prime plus x plus lambda y is equal to 0. So is it a Sturm Liouville problem or not? So let us open this bracket. I'm going to have 1 over x y prime. You can see that it has already formed this. If we expand it, we are going to have 1 over x y prime to be a long process. Since p of s is this, p of s is in form of this plus. So we have to find q of s. So if I multiply this, I'm going to have xy plus lambda y is equal to 0. So what am I going to have? Sy plus lambda y. So my p of s here is what? 1 over x. The coefficient of what? The coefficient of what? Y double prime. So my q of s is the coefficient of what? Y. So is what? X. And my w of x, my w of s is what? Coefficient of what? Lambda y, which is what? 1. So you can see for me that is it a Sturm Liouville problem or not? You can see that what this is what the coefficient of y here is x, so that's why we have it. So for this one to be a Sturm Liouville problem, so let us check if p of x and w of s are constant. W of s is constant here. If p of s is constant, so if I put p is equal to 0, I'm going to have 1 over 0. And 1 divided by 0 is what? Undefined. It means it is not continuous. And remember that when we talk about a continuous function must be well defined and the limit must exist. So it means it is not continuous. That is, it is undefined. So since p of s is not continuous on the interval of what? On the interval of 0, 1. So it is not a Sturm Liouville problem. So since p of s is not continuous, is equal to what? 0. That is, p of s is equal to 0. And when I put 0 is what? Undefined. That is, p of s is not, since p of s is not constant, that is, it is not divine. Since p of s is not constant, then we have what? It's not constant and also it's not continuous. Well, it's not constant, it's not continuous, So test let us check the second to the last. Y double prime plus lambda 1 plus x y is equal to 0. Is it a Sturm Liouville problem or not? So y double prime. So it means if I open this bracket, what am I going to have? So this is lambda already. It means I don't have q of x. What? Okay, let us open the bracket. I'm going to have y double prime plus lambda times this one lambda x, that's lambda y plus lambda x, lambda 1 times lambda x. If I use this one to multiply this, I'm going to have lambda plus lambda x. So if I use this one to multiply this, I'm going to have lambda y to lambda xy. So I'm going to have lambda xy. So from here is equal to what? Is equal to 0. So I want to get for this is also the same. If I open this bracket, I'm going to have this as well. You can see that here our p of s, the coefficient of y double prime. So what is our p of s here? Our p of s here is 1. That is, the coefficient of y double prime is 1. So here we don't have q of x because the coefficient of what? Of y will give us q of s, and we don't have the coefficient of y here. And this is what? The coefficient of lambda y is this. So it means my q of s is 0. Then what's my w of s? My w of s is what? Coefficient of what? The coefficient of what? The coefficient of lambda y, which is what? 1 plus x. So 1 plus x. So is this a Sturm Liouville problem or not? Remember that for it to be a Sturm Liouville problem, it must be a continuous function. And when we talk about this, I want to explain this again. 0, 1, this interval, this is an interval, is a closed interval. That is, our 0 is less than or equal to x, or is less than or equal to 1. It means our s is equal to 0, s is equal to 1. And if you put when s is equal to 0, our p of s must be continuous. That is, when we have a number which is 0, our next number which must be what? 1. It means if I have 1, next number of 1 is what? 2. So if I have 0, next number of 0 is what? 1. And it must be for a constant. That is, it must be a positive. And if it is continuous and if it is not positive, it means it does not satisfy a Sturm Liouville problem. It must be continuous. And when it is continuous, it will be a positive. That is, it will give us what? A positive value. So if I now, you can see that our p of s here is 1, our q of s here is 0. So our w of s here is what? 1 plus x. It means if our w is 0 here, if I put our s is equal to 0 here, I'm going to have what? 1 plus 2. 1 plus 0 is what? 1. That is 1 plus 0, which is 1. You can see our p of s is constant. then our W of S is what? Is also constant and it is continuous. It means after 1, what did I have? Next number after 1 is what? 2. You can see it is continuous as well, and it's what? It is what? It's a positive term. So it means P of S is continuous. Since P of S is continuous on interval of what? Since P of S is continuous and W of S is also continuous, that is, they are what? P of S is a positive term and what? W of S is what? Positive term. But our Q of S can be any number, can take a negative, can take any value, but we have to consider that our both P of S and W of S must be what? Must be continuous and must what? Be positive value. So it means from here it is a Sturm Liouville problem. Sturm Liouville problem. So let us now consider the last example I have. Exponential 2x y double point plus exponential 2x y point plus lambda y is equal to 0. So let us make this as a form of what? Sturm Liouville problem. I'm going to have exponential 2x y point prime outside plus what? Plus lambda y is equal to 0. Because if you take this, if you open this one, you are going to have this. So what are we going to have? So our P of x here, is what? Our P of x here is exponential 2x. Then that is our Q of s. We don't have for Q of x. Our Q of s is 0. Our W of s is the coefficient of lambda y, which is what? 1. You can see that if I put at s is equal to 0 here, I'm going to have 1. So since P of x is continuous on interval 0, 1. So it is a Sturm Liouville problem. Sturm Liouville problem. So you can see that since it's continuous, so this is how to determine when we have a form of this, is it a Sturm Liouville problem or not. I hope you find it interesting. Don't forget to subscribe to my channel.